everyone, my name is Sadam Khan. I'm a doctoral candidate at University of Auckland and first author for DC fault detection using time derivative of high pass filter response in multi-terminal DC system. Abhishek and Nirmal are second and third author, and I will be presenting it in 50th Icon Annual Conference 2024. Most renewable energy resources like windmill and solar panels provide energy efficiently and economically in the form of direct current. Therefore, in conventional AC network, more power conversion stages are required as illustrated, which will incur more power conversion losses along with reactive power losses in transmission. However, as illustrated in modern DC grid, fewer conversion stages are required, which eases the renewable energy sources integration with enhanced system capacity and efficiency. The low structure cost and clearance area needed for DC transmission cause it have two conductors only and low voltage levels for the same power transmission capacity as shown in figure. There are two types of power converters, current source converter and voltage source converter. Current source converter are line commuted as they use old thyristor technology, so they only turn off on zero crossings. Therefore, it depends on AC system and require large reactive powers to work. Further, it has no asynchronous system connection supported and no multi-terminal system capability. On the other hand, voltage source converters are self-commuted as they use modern switching technology, provide independent active and reactive power control. They can support asynchronous system connection and can work with forthcoming multi-terminal DC system. However, widespread use of multi-terminal DC grid is impeded due to immature fault protection systems, causing the freewheeling diode inside the voltage source converter to be destroyed immediately in case of faults. Therefore, this paper will cover this gap and introduce time derivative of high pass filter current response to detect the fault ultra fast as required. This fault detection technique is tested with a simulation of multi-terminal DC system with 4 terminals in MATLAB Simulink environment for given specification and methodology elaboration. This method utilizes a 6th order high pass filter with a cutoff frequency of 150 Hz to focus high frequency DC link capacitive discharge as fault signature. Then, derivative of this high pass filter response is taken to detect the fault ultra fast. A line-to-line fault is created between VSC1 and VSC2 at 0.6 second. As shown in the graph for time derivative of high pass filter response, a sharp spike is seen at 0.6 second in both lines, plus line 12 and minus line 12, which indicates that it is a line-to-line fault. If we zoom in this signal, we can find that it detects the fault just in 5 microseconds. Similarly, line to ground fault is created and only a single spike is observed in the high pass filter response of plus line 12, which indicates that it is a line to ground fault. Further, it is not impacted by AC load variation and AC faults. So in conclusion, we can say it detects all DC line to line and line to ground faults just in 5 microseconds. It's unaffected by AC load variation and AC faults and applicable in multi-terminal DC systems.